This video is about solving linear equations with variables on both sides and special cases that can occur. So periodically when we are solving, something strange is going to happen when we start to solve our equation. So in A, we're going to see that there's parentheses and distribute this 2, which gets us 2x minus 8 equals 2x minus 8. So some of us may notice right away that there's the same variable and the same constant on both sides. If not, just subtract your variable. So I'm going to subtract 2x from both sides, which means that my variables cancel out. I'm left with negative 8 equals negative 8. Now, there's no more variables, but this is a true statement. Whenever you get a true statement, this is called infinitely many solutions. It means that no matter what value you put in for x, the equations are going to be balanced on both sides and equal each other always. In B, again, I see parentheses, so I'm going to distribute the 2. So I get 4x plus 10 equals 4x minus 24. This time it's the same variable on both sides. So when I subtract 4x from both sides, I'm left with 10 equals negative 24. This time, that's not true. 10 is not equal to negative 24. When that happens, we call this a no solution. So let's look at a few more examples solving the problems. Remember, there's 3 things that can happen when we solve. Infinitely many solutions, no solution, and then yesterday's video showed us that we can get x equals some type of value. So let's solve each problem. Number 1. First, there's parentheses. So I'm going to distribute the 4 into the parentheses. 12x minus 40 plus 2 equals negative 38 plus 12x. So when I combine like terms with my 2 numbers over here, I get 12x minus 38 equals negative 38 plus 12x. So move your variable to one side. I'm going to subtract 12x from both sides, and I'm left with negative 38 equals negative 38, which means that I have infinitely many solutions. Number 2, to start this problem, I need to distribute because I have a set of parentheses. So I'm going to distribute 2 to both sets of parentheses. I get 10 plus 7x minus 3x equals 4x plus 24. Now on the left side, there's 2 x values that are like terms that can be combined to become 4x. So I have 10 plus 4x equals 4x plus 24. I'm going to subtract 4x from both sides. I get 10 equals 24. That's a not true statement, so this would be a no solution. Number 3, I need to distribute my fraction, which is 1/2. So remember, when I distribute 1/2, half of 10x is 5x, half of 8 is 4. On the other side, I can combine my x's. So 10 plus 3 is 13x minus 12. This time, my x values are different, so I'm going to subtract the lower x, so minus 5x from both sides. I'm left with 4 equals 8x minus 12. And I'm going to add 12 to both sides. So 8x equals 16. My last step to solve is to divide both sides by 8. And x equals 2. Now, instead of just talking through a problem, we're going to use the table to show and explain all of our steps. So in my steps, I'm going to write what my original problem is first. So step 1, 5x minus 15 equals 11x plus 3. And we're just going to say that's our given equation. So in step 2 then, I need to move my variables to both sides. So I'm going to subtract 5x because it's the smaller variable. So in step 2, I have negative 15 equals 6x plus 3. I'm going to explain how I got there. So my explanation is subtract 5x from both sides. It's very important that you say from both sides because when you're solving, we need to keep our equation balanced. So we have to subtract from both sides, not just one. Then in my next step, I got the variable by itself, but I also need to get the constant by itself. So this 3 needs to move away from the x. So I'm going to subtract 3 from both sides. And I get negative 18 equals 6x. And in my explanation, I would say subtract 3 from both sides. And then in my final step, I'm going to divide by 6 on both sides. So I'm going to show my work. And I get my final answer, x equals negative 3. I'm going to explain how I got there. So I divided by 6 on both sides. Make sure that you're always saying on both sides.